Okay, so what we have here is a number line. So it says, which of these following sentences is true? So one thing I found is a lot of people will see a number line and they think they don't know what to do with it. But it's just like how it looks. It's like a ruler, like basically everything in the, every time you have a tick, it represents a certain amount, and sometimes there'll be numbers there, sometimes not, and we can figure out how big they are in between just by kind of dividing them up. So this goes from 6.0 to 7.0, and only one of these statements is going to be true. Okay, so, but even without that, if we look at the question and read those out, we should be able to like think in our head, well, this is true or this isn't true. Okay, so I'm not going to use any of those, but like if I was going to say a statement like, so say I said that 6.6 is greater than 6.8. You should be able to read that and say, well, that's not true. 6.8 is bigger than 6.6. And you'll answer accordingly. What ends up happening is when we see the decimal numbers, some people will make a mistake thinking like, say, like 5.42 and say 5.5. They'll think the 5.42 is bigger because they think, well, 42 is bigger than 5. But you have to remember that this 5 is like 5.50, and so really that's like 50. 51 hundredths and 42 one hundredths. So don't get caught on that. But otherwise, it's, yeah, just read it out, and if it sounds right, it's right. If it sounds false, it's false. So just trust yourself on that one. Okay, so here we have a question where we've got the words of like the written words of a number, and we need to be able to go between what we hear as a number and what the number is written. And some people have a hard time with that. But this one here, if we read it out loud, so this particular one is 402,352. If we need to write that, we select the one. If I was thinking of another one, so say I did 5,000 200 76. That would go, I got 5,000. So after my thousands, I always do this. And the one thing that always happens is they go in sets of 3. So in this particular one here, you say like how many millions, how many thousands, how many hundreds, right? And then so we have 5,276. So that'd be that one. If I had a number like this one, I would read this part here, 557. Thousand 425. Okay, so we're always taking these sets of 3, right? So 557, 425. If we had 725 million, 522,000, 475, 725 million, 522,475. That's all we're doing there. So here we've got a rounding question. So when we're rounding, the reason we round is because sometimes we don't need the precision of all the say all the way to the ones, and that it's not relevant. Or say we're dealing with things that were in the hundreds of thousands, and we wanted to add some things together where, how in the last couple digits, say how many ones and tens aren't important. And if we round, say, to the nearest hundred, we can add the hundreds up, and it's a little bit easier number to deal with. So the question with like this, what we want to do when we're rounding is we're identifying the place that we're going to be rounding to, and then we look at the next digit to see whether it's going to cause it to go up or to stay where it is, because in rounding we're trying to see whether it's closer to the next one or to the one it is. And so in a question like this, where we're looking at the nearest hundred, we need to find the hundreds. Okay, so I'm going to do it with a different question, different number. So say it was 815,732. Right? If I'm going to round it to the nearest hundred, I'm rounding it to the nearest 7. Rounding the 7 here. And so basically I want to know whether it's closer to 815,700 or 815,000, and the next higher one would be 800. And so when I'm deciding whether this goes up to an 8 or staying as a 7, that's what I'm doing. It's one of these two. And the nearest hundreds are 815,700, 815,800. Okay, which one of those is it closer to? Well, if we think about it, and we look at 732, and we look at 700 and 800, is 732 closer to 700, or is it closer to 800? And I think most of us would pick 700. And it turns out that this is the right answer. Yeah, the way we were taught, or the way I was taught in school, was we'd have the 815,732, and I would usually underline the hundreds place, and then I look at the next digit. And the rule I would have used was, if that digit is 5 or more, those are going to cause it to go up to the next one, and so it would be to the 800. And that's because when you get to 750, which would be with 5 here, it's going to become closer to 800 than to 700. For 0, 1, 2, 3, 4, it just stays where it was at. We fill everything else in with zeros, and we get this answer. Okay, and that's how we do it. Okay, with this question here, we had a number line. Remember, a number line shows all the numbers in a row, just like on a ruler. And the lines in between the numbers that we see, so if we see a 10 and a 12, we know the one in between is 11. 11.5 would be here, and so on. And so in this question here, all it's asking us is which points are less than 13. Okay, so we want to be able to pick out which of those points are less than the number 13. Okay, not equal to, not over, but less than. And we should be able to pick that out there, no problem. In this song here, we have a music playlist of a certain number of songs of different types, and we're looking for the total amount of songs. So I'm going to put some different numbers in here just so you can see. So we'll say there was 25 hip-hop songs, we'll say there's 12 rock songs, and we'll say there's 63 pop songs. Okay. And so anytime we have a bunch of different items and we're asking for the total number of items, we need to have the sum. So we need to know how much those add up to. And so basically we can create a little equation to be able to do that. Well, if I'm doing that, I want to know how many hip-hop songs and how many rock songs and how many popular songs. Remember, the plus sign just means and then count up a certain amount. So this is like count up to 25 and then count up another 12 and then count up another 63. We're going to get to the total. We get 25 and 12 is 37 and another 63. I could go 37 and 3 is 40 plus I got 60 left over and I get 100 even. Okay, so anytime we have that, like the total number of something or how many altogether, it's an addition, right? So this question here, we've got a garden and it's shaped in a rectangle. So anytime we're doing a question, I'm kind of drawing stuff out and thinking about it. And it says the rectangle measures 14 meters long and 10 meters wide. And I've changed it from the original question. What's the distance around Mia's garden? Okay, so if I've got a garden that's shaped like a rectangle, I know how to draw a rectangle. And rectangles always have a long side and a short side, and we call them the length and the width. It doesn't really matter which you call which, but one side is going to be a certain length, the other side's another length. Okay, and so I'm going to put the long one here and the short one here. And the thing with the rectangle is that it's going to have two sides that are the same length. So the one opposite to here is going to be 14. And the one opposite to here is going to be 10. Okay, so we should know that. Okay, it's a rectangle, so it should have two sets of two equal sides. And so this question here, we've got a 14 and a 10, and we've got those marked on the diagram, and then it says what is the distance around. So we want to know how far it is all the way around here once. Okay, and a lot of times people get mixed up and they go, well, I can't remember if I multiply or I add or divide or anything like that. But if we think about it and we look at the real situation, if I asked you it in a real world thing, you would know what to do. Because anytime you need to measure around something, whether it's a yard or a garden or a book, you're going to measure this length, then you're going to measure this one, measure this one, and measure this one. And you just add them up as you go around. That's going to give you the total length. Right? That's what we call a perimeter, but it's just a fancy name for measure it, how far it is around. Okay, and you can do that for any item. You can just measure any parts of it as you're going around and keep adding them up. So you don't need to remember a formula for perimeter of a rectangle or anything like that. That's just what you would do if you were asked to do it. If I said, can you measure around this garden? You'd have a certain length of tape measure. It's probably not going to go the whole way around. So you measure each side, keep adding them together. Okay. So in this one, so it doesn't matter where we start, but we'd go 14 and then count up another 10 and then count up another 14 and then count up another 10. And there's lots of ways you can add this up, but 14 and 10 is 24 and another 14 is 28 or 38 and another 10 is 48. Some people would go, oh look, I got two 14s, that's 28, and I got two 10s, that's 20, and add those together is 48. Or some people might go 10 plus 10 plus 10 plus 10 is 40, plus these leftover 4, so I got 8. Whatever way you get up to it, they all get you to 48, and that's the cool thing with math is there's all these different relationships of ways we can break numbers up to make them easier for us to add up to the answer. Okay, that's all you're doing. So in this question here, we've got a workbook has some problems, and I'm going to just change these numbers here to something different. So 954 and 722. So it says there's a workbook here, and there are 954 problems. And we've done 722 of them. Okay. And so this is a thing that if I gave you the situation and told you to find how many are left, you could go in and count up how many that are not done. That'd be one way to do it. But if you were counting up and you knew how many you had done and how many there were, there's a way to figure out how many are left. Okay, and so if we think of it like it could be anything that you have. So it could be the amount of candies you have and how many you've given away, how many do you have left. Okay, and most people are going to go, okay, that's just a subtraction. They'll do the 954 minus 722. Okay, and they do their work and get their answer, and that would be the answer. One thing I want you to do is try and think of it a little bit different way, and think of it like this is the number that you've counted up to. And then every time you do one of these questions, you're counting backwards one. And once you've done all of them, you're going to be counted all the way back to 0. Okay. And so really what's happening here is you've counted up to 954, and then you've counted backwards 722, which I know I haven't talked about, adding negatives and things like that, but this is just a little taste of some of the stuff we'll talk about. Is like negative just means counting backwards. Okay, and if I'm saying that this means and then, so instead of counting up, it's going to be counting down, and we're all capable of counting down. And if you did that, you went 954, 953, 952, all the way 722 down, you're going to get to a certain number. You could do that, it would just take you a really long time. So what we can do is we could actually put this into your calculator as 754 plus negative 722. So remember, don't use the subtraction sign. You'd want to use the little negative sign. Sometimes it's in brackets. And you're going to get this same answer. Okay, it's just a little trick for, well, it's not a trick, it's actually a more helpful way to think of subtraction is thinking of it as adding or counting backwards. It's instruction to count backwards. Okay, so when you get this situation, we've got this many things, we're taking some of these things away, it means we have to count backwards. We're going to get to this 232. And remember, you can use your calculators here. Most people have a phone that you're able to use. There's no reason to not use devices that you have handy. So the key thing here is recognize this is a subtraction problem or adding a negative problem, in which case you can get this set up to a way that you can put it in your calculator and solve it, or if you remember how to do it this way, that's fine. But you've got a calculator. You can actually go, hey Google, let's see if my phone will do it right now. Hey Google, what is 954 minus 722?
The answer is 232.
Thank you. So it's that easy.
You're very welcome, Mark.
Oh, thanks. That's so kind. The thing is, if you have a phone, and so if you have an Apple phone, you've got Siri, you can ask questions to. If you have an Android phone, you've got Google, you can ask. And I found myself even lately, like instead of pulling out the calculator on the phone and typing something in, I realized, oh, I can just say it out loud and it'll tell me. And all kinds of random things, like whether the weather or whatever. So this isn't an advertisement for Google, but it's just letting you know that you have that assistant on your device. And it's like having a personal butler, really. All right. Okay, so we've got someone buying a patch of land. I'm going to change these numbers here to, we'll say it's 60 meters long and 40 meters wide. Okay. And so it says Aisha bought a rectangular patch of land that is 60 meters long and 40 meters wide. What's the area of the land? Okay, so area is a concept that we get faced with a lot of times. So anytime we're thinking about like how much area something covers or takes up, we're looking at how wide it is and how long it is and figuring out how much squares fit into there. Okay. And we have to define what size those squares are, and then we're figuring out how many squares. So in this case, it's meters squared. And so that means that there's going to be squares that are 1 meter by 1 meter, and we want to know how many of those are going to fit into this area. And so if we think of this, it's a rectangle. This is a fairly easy one to do. And it's 60 meters this way it's 40 meters this way. And in school, you probably would have learned, okay, the formula for area of a rectangle is length times width. Just multiply length times the width. So 40 times 60 is your answer. And that's fine, but it's more important to understand why that's the formula, because then you're going to be able to figure out the formula for any shape. And if I want to know how many of these squares, and this isn't drawn to the right scale, right? This is way smaller than what will be in here. What it means is that there's going to be 60 squares wide, or this way. And because this is 40 meters, we can fit in 40 squares this way. Okay, and those are going to make squares like a grid that are 40 down. So we're going to have 40 rows of 60. No, that's not right. Yeah, of 60 squares. No. Hold on a sec. We're going to have 40 rows of 60 squares. Yes, because each row is going to be 60 squares wide. And we're going to have 40 of those rows. Okay, so I had it right. So 40 rows of 60 squares. So if I drew those all out and I asked you how many squares there are, you could count them up and you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 60, 61, I'll count all the way up to 120, then 121, count and keep counting like that. But hopefully after a while you'd realize, okay, every one of these rows is 60, and I got 40 of those. 40, I could go 60 plus 60 plus 60 plus 60 and do that 40 times. And that's still going to take me a long time. Or I can recognize if I have 60 added to itself 40 times, that is 60 times 40. Okay, that's where that formula comes from. That if we understand that, we're going to get it, we're going to be able to use that in other situations. So when it's not a perfect rectangle, we're just trying to figure out how many of those 1 meter squares fit on here. And once we can draw it out, we could just count them. But when we have that ability to go, okay, well, if I'm adding these and we got this pattern, I can turn my addition into a multiplication because I'm adding the same number over and over and over. Once we recognize that stuff, then that's where it really unlocks things for us. Okay, better than thinking, well, area is length times width for a rectangle. Okay, that's useful, but it doesn't help us understand the concept of area. Okay, so it's really important that we understand where that formula comes from so that we can create it. And because a lot of times I've been getting people who are saying things like, well, do I add the 60 and the 40, or do I multiply it, or do I divide it and stuff like that? And so we're just trying to guess and remember a rule when really we want to understand why that rule is there, how they created that rule. And that length times width is the number of squares across times the number of squares down. And that tells you you got 40 rows of 60 squares, which is 240. And we call them square meters because literally that square is 1 meter square. We have 240 of them fitting in there. Okay. All right. So this here is a question where we've got 3 people. So we've got Fiona, and we've got Madeline. Oh, we got Michelle first. Fiona and Madeline. And it's telling us about the relative ages. So I'm going to change some of these numbers in here. So I'm going to say that Fiona is well, we'll leave that as twice. Michelle is, we'll say, 4 times. It's Fiona, and we'll say that Madeline is 3 years old. Okay, so this is a question where really, like, we know the relationship between Michelle and Fiona's ages, and we know the relationship between Fiona and Madeline's ages, and we know Madeline's age, and so we're trying to find Michelle's age. So it's a little bit tricky, but if we do, if we put in what we know, so we know that Madeline is 3, okay, and we know that Fiona's age is twice Madison's age, 2 times. And we know that Michelle is 4 times Fiona's age. So, like, knowing that, we can use 2 times Madison's age to get Fiona's. So we go 2 times 3, and we find out that she is 6. Okay. Michelle is 4 times Fiona's age, so she's 4 times 6, which is 24, and we're done. Okay, so all we're doing is we're finding the relationship between one person and the other to figure out, so we kind of had to figure out what Fiona's age was using Madison's age, and then once we got that, we could get Michelle's age. So we knew information to be able to get the answer. We just had to figure out what to do with that information. Okay, so this is asking which expression can be used to show a group of 27 players divided into 3 teams. So basically, like, an expression that would be the way that we could show that happening mathematically. Okay, so I'm going to do this with a couple different numbers here. So let's say 24 players divided into 4 teams. And so with division, what it's doing is, if we want to divide 24 players into 4 teams, so that'd be like we have one big group of 24 people, and we want to divide that into 4 equal teams. It's like dividing in half and then dividing each of these halves in half. Okay, so that's what we would be doing in reality. The way that we can show that to come up with an expression that could be used to calculate it, well, the answer that we would have come to would have been 6, right? 24 divided by 4 equals 6, right? This is the expression. 24 divided by 4, or divided into 4 teams, is what's going to be representing that situation, okay? So if we had 30 candies divided into 6 piles, it'd be 24 divided by 6. So this is just a thing, taking the words and trying to connect it to the mathematical expressions of it, right? And so in here, we'd be looking to see what this is. In this, we had 27 divided by 3, 3 over 27, which is like 3 divided by 27. It can't be that. 27 divided by 9, that's a different relationship in there, because 27 divided by 3 is 9, but we don't want to get caught by that one, because we're not dividing 27 into 9 groups of 3. We're dividing 27 into 3 groups of 9, right? So 27 divided by 3 ends up being that one. I guess I just gave you the answer, but same with this one, we could cross out, this one we could cross out, not just because they're in different form, but because it's not 9 divided into 27 groups, right? It's 27 divided into 3 groups. Okay. This is the question here where we're looking to turn a decimal number into its word form, so to represent what that means in words. And so if I was reading this number, I would read it as 5.470. Right, as we're doing decimals. When I'm doing it like in this form, this isn't usually a way we would write it, but it's good in helping us understand what that actually means. And so kind of the same way that we pulled apart big numbers into their 100,000s and 10,000s and thousands and that sort of thing. In these, we're going to state the decimal part of it as tenths or hundreds or thousands or 10,000s and things like that. So this particular one, 5.470, that means, so this part here is 5, and this here, we have 470 of something. And so this part here, it represents some portion of this number that is between 0 and 1. Okay, because if it was over 1, then it's going to move this up to a 6. So this is a number between 5 and 6. And so this part tells us how far between 5 and 6 it is. So is it 5.0 or is it 6.0? Is it 5.5? So this one here is 5.4, which would mean like there's 4 tenths there. Right? There's 47 hundredths. There's 470 thousandths. So when we get to this place, because this is the tenths, hundredths, thousandths. So what this means, we're always going to go whatever the furthest part on the right, that's going to tell us what we're counting. And so this case here, we're counting thousandths, and it's saying there's 470 thousandths. And what that means is if we took 1 and divided into 1,000 pieces, we're talking about 470 of them. So this here is actually just another way of writing the fraction 470 out of 1,000, which is 470. This here is 1,000th. We have 470 of them. Right? So 470 thousandths. And so it's kind of a different way to look at it, but it actually helps us understand what it means more, I think. So it's 5 and 470 thousandths. If it had been 5.47, we would look at that and then go, well, that's tenths, hundredths, and it's 47 hundredths. Okay, if it had been 5.4, that's 5 and this is measuring tenths, 4 tenths. Okay, so that's how we break those down, and it actually is really helpful for us to understand what those decimal part of the number, the stuff to the right of the decimal, what it really means. This is another number line. So whether it's decimal numbers or whole numbers, it doesn't matter. So when we look at this, we should be able to see, okay, this is all the numbers between, with all the tenths between 6.0 and 7.0. If we were to guess what something was in between here, we can go, well, that's between 6.4 and 6.5. Maybe it's going to be 6.45 or 6.46, something like that. In this here, we're looking to see which of these statements is true. And so it's just a matter of going, well, 6.8 is greater than 6.6. Even if we didn't have a number line there, we need to be able to look at that and go, well, is that true or is that not true? Is 6.4 bigger than 6.6? Is 6.4 less than 6.2? Is 6.3 less than 6.0? Okay, so the way we can do that with a number line is if we put the numbers on here. So if we put the 6.8 here as, say, my A, and 6.6 here as B, greater than means it's to the right. So the bigger, greater than or bigger than is always towards the right. Okay, the things on the right are bigger than, the things on the left are less than. And so you can use that to help you answer that question. This is a question for rounding decimals. When we go through that, it's the same rounding rules, where we pick the place that we're going to round to, and we're going to look at the number to the right to see if it's 5 or bigger. If it's 5 or bigger, we round that number up. If it's below 5, we drop everything off after it and just leave it. Okay, so in here, first thing we always want to do is find the place that we're rounding. And so it says round to the nearest hundredth. I know in this question here, it's kind of, the comma that was there looked more like a decimal. So just be careful of that. There would never be like 2 decimals in a number. We'll try to get those changed. So we have here 4,524.722. So that's like 722 thousandths. Remember, because we were saying this is the thousandths. We count these up, 722 thousandths. If we want to round to the nearest hundred, that's going to be rounding this place. Okay, and so it's a 2. So it's either going to be a 2 or a 3. We have to decide, is it closer to be 72 or closer to 73? And if we look here at the thing to the next, it's a 2. So really what we're looking for is it 0.720 or is it 0.730, which is it closer to? And if we look at this, 722 is closer to 720. Okay, it seems pretty obvious that it's going to round to the 0.72. Okay, if we had applied that rule, we'd go look at this number here. We go, well, it's a 2. That's less than 5, so it's going to stay. It's not going to round up. Okay, and it's just going to look like that. Our answer would be 4,524.72. Okay. If this number at the end had been a 5 or bigger, it would have moved this up to a 3. Okay, all we're doing. Okay, so on this question here, we're looking at the relationship between a picture that's in front of us and the fraction that it represents and the equivalent percentage that it represents, because a fraction can always have an equivalent percentage. Okay, and we need to be comfortable going between fractions and decimals and percentages. And so in a question like this, that's what we're going to do. I'm going to fill in a bit more of this just so that we have a different one to work with. So I'll fill in with some more blue here. And we'll say all these ones are filled in and all the way to here. Okay, and so if I was going to come up with a fraction that represents this, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up and 10 across. So there's 100 squares. And it's saying what percent of the grid is shaded. I've got 10, 20, 23, 26 out of 100. Oops. So 26 out of 100. And remember, we can always reduce those down. Like if 2 goes into both of them, we could say, well, that's like 13 out of 50. We can't reduce any further than that because 13 doesn't go down. But 26 out of 100. If I told you, say you did really bad on a test and you got 26 right out of 100, and I asked you what's your percentage, well, 26 out of 100, you would literally, that tells you your percentage, right? Because percentage literally means per 100, right? So 26 out of 100, or 26 100ths, means 26%. And the one thing that people get caught on a little bit is sometimes they'll see this and they'll go, well, it's 26 out of 100%, but that's not right, because the percent symbol actually means out of 100, right? And so this here, 26%, literally means 26 out of 100, okay? And so to go between fractions to a decimal, all we have to do is put it in a calculator, and we'd go 26 divided by 100, and we'd get 0.26. So that's the decimal version. And to figure out what it is as a percentage, you multiply that by 100, and you get 26%. Okay. And so using those rules, let's go in and look at that, figure out what it would be as a percent. Okay. And so we want to know what percent is shaded there. And if you came up to a number and say you thought it was 14 out of 100%, that's like saying like 0.14%, which is way less than 1%. If you looked at this, you know that that's not less than 1%, because 1% would be one whole square, with the rest unshaded. Okay, so that's where we want to connect what we know and what we see to the terminology, and that's going to clarify it so that we can use it more effectively. So here we've got Lola taking a train from Paris to Nice. There's two places in France, I guess. So maybe it's not Paris to Nice. Maybe it's standoff to Fort Macleod or something. I don't know. Or to Calgary. The distance between the two cities is 921,000 meters. And that's another one where the comma's not showing up too good on here. It says the train travels a speed of 307 kilometers per hour. How long will it take her to travel that distance? And so in here, there's a couple little things we need to watch out for. We want to make sure that we're in the same units, because we can't, if we know the distance in meters and the speed in kilometers per hour, those don't match up. So we're going to have to get them both in the same units. So there's something there that's going to be a unit conversion necessary. And you might say to yourself, well, I don't know the formula for figuring out time if I know distance and speed. But you might not have taken physics class and learned the formula V is equal to d over t, but you probably have the skills that you would need in order to figure it out if you draw it kind of out here. So if I draw out this situation, let's say Paris is here, and I say Nice is here, and this is the distance between them. It doesn't matter if it's straight or not. It's going to represent 921,000 meters, right? And we'll call that our distance. It says the train travels, so we have a train. No, it looks more like a truck, but you know what I mean. Doesn't know how a train looks, something like that. And so we have a train, and it can go 307 kilometers per hour. Okay. And we're going to figure this out here. Okay, so if we look at this and we go, well, it's 921,000 meters. Okay, so we know that we need to recognize that that wouldn't be, so say if we read that and we read it as kilometers, 921,000 kilometers would be a absurd distance, right? Like it's way longer than going around the Earth multiple times. So it can't be in kilometers. So, and these are both places in France, so it has to be a reasonable distance, right? So we should recognize there that wouldn't be an appropriate number for a distance to be 921,000 kilometers to travel. Okay, because you know, if you think of it going 100 kilometers an hour, even, like, that would take forever. So we want to recognize there that, okay, these units aren't the same, so I need to get this into kilometers. And then that's where we have to be comfortable doing our conversions. If we remember, there's 1,000 meters in a kilometer, and so we can just drop off 3 zeros at the end, because that's like divide by 1,000. right? Because of 1,000 kilometers per meter. Sorry, 1,000 meters per kilometer. And we get 921 kilometers, which sounds more reasonable. Okay, still not a short distance. So with 921 kilometers, and the thing goes 307 kilometers per hour, that's where, even if we didn't know the formula, if we think about a situation where we've gone a certain distance in a certain amount of time and tried to figure out how long it was going to take, and just try and think about, well, how would we figure that out? We can even create a situation that's an easy one to think of. So something you know. So say it was just using simple numbers. So say it was say you knew you could go 100 kilometers per hour, and you wanted to know how far you would go in an hour, right? After 1 hour, you've gone 100 kilometers. After 2 hours, you've gone 200 kilometers, right? And so on. Even if you didn't know the formula, you could go, well, this train is going to go 307 in the first hour, and it's going to go another 307, so it'll go up to 614, and then in another hour it's going to add another 307, and we're going to get to 921. Okay, so you could do it that way. So there's all these different ways we can relate those values in ways that we know, even if we haven't learned that formula. We don't need to be trapped by that idea that, oh, we had to have learned that, because you have the skills to be able to deduce or deduct, like basically to solve this mystery without that extra knowledge. You would be able to solve this. And so that's what we want to work on releasing ourselves from attempting to solve problems that we think we don't know how to do, right? It's not true. You do have the skills to do this in a different way, and in a way that's going to be making sense to you. Even if we didn't know to do that, if we look at these answers, some of these answers there's no way it could be, right? Like, so if you think about this, you could have done, well, in 3 hours at 307, that train is going to go 921 kilometers. In 3,000 hours, it's going to go 921,000 kilometers. In 300 hours, it's going to be 92,100 kilometers. And in the third hour, it's going to be a little over 100 kilometers. It's going to go. And looking at that, you'd be able to go, well, which one of these is it? Well, it's not these, it's not this, it's this one. And so that's where, when we see a question we don't know, we haven't seen before, and we're like, oh, I don't know how to solve this. Sometimes, like, 3 of the answers are like, there's no way it could be true, right? And so if we go in and start going, well, how far would we go in 3 hours? How far would it go in 3? You can rule stuff out that way. So there's not one single way to solve something like this. It's the process of trying to relate it to things we know, right? And yeah, like, not limiting to ourselves or thinking that we can't do it because we haven't learned how to do it or someone didn't tell us how to do it. We can actually figure things out that we don't know. We can teach ourselves, right? And so we want to work on that for sure. Okay, so this is another one that's like a problem solving one. And we're just looking to see, this ends up being ratios. And so I'll switch this up a little bit. I'll change the numbers to free throws to be, we'll say 50, and we'll say 50 say 4 out of 5. No, I'm going to change this one to be this. Okay, so we have a high school basketball player. They've taken 45 free throws. And apparently there's an analyst there, so this is I guess a team that gets followed by the media, and they've got people who are looking at it, or maybe it's someone from the other team, I don't know. So they've determined that this particular player makes 4 out of every 5 of their free throws. How many free throws did the player actually make? So what we want to know is how many out of 45 did they make? If they're making 4/5 of them, so 4 out of every 5 they make. And so there's a whole bunch of different ways to solve this. And if you know how to work with ratios and you can solve for the missing one, and that a lot of people go, oh, cross multiply and divide, and that works. But most people don't know why it works. And so let's take a look here at some different ways that we could do it. If we know that they make 4 out of every 5, well, we could say 4 out of 5. And then that means they would make 4 to the next 5, so they'd be 8 out of 10. And then 4 to the next 5, so it would be 12 out of 15. And then 16 out of 20. And what happens is these are all equivalent fractions. Okay? And so every time, like this one here, I'm multiplying the top and the bottom by 2. And then I'm multiplying by 3. Then I'm multiplying by 4. And then I would get 20 out of 25. 24 out of 30. 28 out of 35, 32 out of 40, and 36 out of 45. So this 36 would be the answer there. We could do it that way and just kind of count up. Well, 4, keep adding the 4s up. How many times do I have to multiply 5 to get up to 45 with a 9? So I have to multiply 4 by 9. And that's what happens when I do the 45 times 4 and then divide by 5. It does come out to 36, which is what is up here. But it's more helpful for us to understand what that actually means, or how we did that. Okay. The other way to look at it, you could say, well, that's 80%. 4 to 5. So 4 divided by 5 is 0.8. I multiply that times the 45, I get my answer, right? And that's kind of the same thing as doing the cross multiply and divide, because we're doing 45 times 4 divided by 5, which is like 45 times 4/5. So they're all doing the same thing, but even if you thought of it a completely different way and you did it this way, that's perfect. It's actually better if you understand that it works this way, and then being able to use this as a trick to do it faster is great. But when you just learn the trick without understanding what it's doing, or understanding like, oh, we're finding 80% of 45, right? And so like I've seen lots of people who are like so good at like calculating like batting averages and all this stuff, like complex stats for sports, or recording stats, doing analysis of stats. And there's a big thing now with like sports analytics, and there's like really good paying jobs in that. And it's actually really cool, interesting math stuff to do. But yeah, like people who think they're not good at math, but then they're like spitting out statistics, and they know, okay, well, if he only goes 3 for 5 today, or his average is going to go down to this, and like that's that part of the math that I'm really excited about connecting to, because there's a lot of people with a lot of math skills that could be putting it towards things that are going to make a difference in the world, right? So And even just not feeling like they're not good at math is a benefit. So that's what we're working on here. All right, so here we're looking at a diagram of a pie. So this one here is a pie where the orange pieces are the pieces that are remaining. In my diagram here, the one I'm going to do, this is a pizza, a delicious pizza, and there's 3 pieces remaining, and then the yellow represents where there used to be pizza. So yeah, and in this question it's saying basically how much of the pizza remains. Okay, so in the question we got to be careful if it's asking how much of the pizza has been eaten. It's going to be different than how much remains. So if I'm going to do both of those parts. So how much remains is how much is left, how much is still there. So 8 equal pieces, each of those pieces we call an eighth, right? So this is an eighth, and this is an eighth, and this is an eighth, okay? And so really, like if I was saying it like literal words and I called each of these pieces an eighth, how many eighths do I have? I've got 3 eighths left, right? I've got 3 eighths. That's not, like if I got used to using that term of that, if I broke something into pieces, 8 pieces, I call each piece an eighth. If I broke things up into 6 pieces, each piece is a sixth. 4, each piece is a quarter, a third, and so on. And I think of those words no different than if I had said 3 pieces. If I asked you how many pieces you remain, you'd say there's 3 pieces. Okay? So the only thing different here is that we have a special word for what we called those pieces. Because we know it's split up into 8 pieces, we're calling each of those pieces eighths. It means we have 3 eighths. How do we write 3 eighths as a fraction? Well, that literally means 3 times an eighth, which with fractions, we can always just put that number on the top. And we read this as 3 eighths. Most of you already are comfortable calling that number 3 eighths, and you're comfortable saying 3 eighths, but for some reason we're not connecting those two things with like the real life, right? Like that's 3 pieces. Okay, that literally means 3 pieces. And so that's where the disconnect is, where people go, oh, I don't get fractions, I don't get fractions. Well, you do. It's just there's something in the language of it that's missing, and that's the piece we need to fix, because you already know how to deal with the pieces and know how to count pieces and things like that. We're just not sure how to take the question and put it into the language we understand, and how to record our answer in the language that's expected. Okay, so it's more of a language thing, and it's a very, very minor little thing, and it's the connection between this word, this 3 eighths, to being 3 eighths. Which is when we say it out loud, it's the same thing, but when you look at it on paper, you see it as 2 different things. The other question, part of it could be is how much was eaten. And we don't need to get into who ate it or why they ate it or anything like that, because it's irrelevant here. But if we look at this here, there's 1, 2, 3, 4, 5 pieces. Well, what do we call those pieces? Well, there was 8 pieces, so we could just say, well, there was 5 out of 8 pieces. But if we're looking at it and we're going, well, what do we call pieces? Like as fractions, the language of fraction, what do we call a piece? Well, we need to know how many total pieces there are. There's 8 pieces, so each piece is going to be called 1/8, right? And so we have 5 eighths, which we write as 5 out of 8. And so that's that part where we're trying to connect the words that we know and the words that we say with the things that are on the page, because we know this stuff and we use those words, and I've seen it on people's faces when we say like, okay, what do I mean by 3/8? And I'm saying it like that, and they're not hearing it as 3 pieces, and each of those pieces is 1/8 of the pizza. Okay, so that's the thing we want to really concentrate on and really think about when we look at this picture. Okay, we got 9 pieces, so each piece is going to be called the 9th. Okay, how much of the pie remains? I think it says 2 were eaten, so that means there's 1, 2, 3, 4, 5, 6, 7 pieces that remain. So there's 7/9. Well, what's a 9th? It looks like that. How many of them do we have? We have 7. There's our answer. And so when we work through that and we say that out loud and we do that, it makes a connection there with it that that's the thing that we're searching for. That's the thing that we're seeking, is that thing that goes, oh, that makes sense now. If you're not getting that, that's where you need to talk to me, and you need to ask for help so that I can help you find that that aha moment on that. Okay, if it doesn't come to you from listening to this. All right, so this is the last one here. It's converting a fraction to a decimal. So there's a few different ways to do this. And basically it's just recognizing that the fraction is like a division, right? So it's saying 7 out of 15, or 7 divided by 15. So we could actually put 7 divided by 15 into our calculator, and we get an answer as a decimal, and that would be our answer. We could, if we have a calculator where we can put in a fraction, just put it in, and there's usually a button on there that converts to a decimal. Do it and you're done. So it ends up being really easy, as long as we recognize that. Okay, and we want to be using calculators. Like, we have calculators available, and any work that you're doing, like, I don't remember the last time I absolutely was in a situation where they said, oh, I need this number, can you calculate it for us? Oh, but you can't use a calculator, it's not allowed. You got to do that in your head. Like, it just never happens, right? So the only time is in school. The thing is, if we're doing practical work, so like in this case where this is math 10-3, so we're doing more like hands-on real type of math that we'd be using in the workplace, we would want to be using our phones. We want to use your phones for doing unit conversions and things like that. And it's about knowing how to use it, or what things are available, or when we can say, hey Google, what is 7/15 as a decimal? Let's see if she heard me.
On the website getcalc.com, they say 0.4667 is a decimal, and 46.67, 100 or 46.67% is the percentage for 7/15.
Can you repeat that, please?
Sure. On the website getcalc.com, they say 0.4667 is a decimal, and 46.67, 100 or 46.67% is the percentage for 7/15.
Okay, thanks. So I've got like one of those little Google Mini home things that came free with my Spotify subscription. That's been life-changing here when I ask her questions, things like that. So instead of having to calculate it, although she spoke a little fast. I'm not sure if that got picked up by the microphone, but I ended up asking, what is 7/15 as a decimal? And I was given the answer, 0.4667. So the 7 is rounded. It would have been 0.466 repeating forever. So it's more like this. 0.46 repeating, right? Like that 6 goes on forever. Okay, that would be the decimal version of it. You can do it on your calculator. You can, like, any way you can do it, it's fine. If it's a number where this bottom part goes into 100, like, so say it was or say easy ones like 3/4 or 1/2, we start to recognize 1/2 as 0.5, 3/4 is 0.75, 1/4 as 0.25, and so on. And so we start to recognize ones that are more common. If you're in the trades and you're doing measurements with inches and quarter inches and eighths inches and stuff like that, you might start recognizing what an eighth or 7/8 is, and it ends up being in between. So 7/8 is between 3/4, halfway between 3/4 and 1, and so 3/4 is 0.75, and this is 1. This one ends up being 0.8. Well, it's going to be half of 25, so add 12.5 to 75 and you get 875. It ends up that. Because 1/8 is 0.125. It's like half of a quarter. 0.25, cut it in half, you get. And some of you may know these calculations in more detail, more familiar than you need to, and I won't ask you how you know those, but that's beside the point. All right.